Good day to our beloved students. Welcome to our math class. It's a great pleasure for me to teach you and give you the learnings needed for our lesson today. Our objective is to prove the congruence of triangles using ASA postulate. Are you ready to further understand the lesson? Okay, let's get started. How do we prove that two given triangles are congruent? What are the postulates that we have used in our past lesson in proving the congruence of triangles? Today, we will discuss another way on how to prove the congruence of triangles, and that is by using ASA postulate. Before we proceed in our topic, let us first familiarize with the terms used in proving the congruency of triangles. Listed here are the definition of terms used in proving triangle congruency. Together, let us discuss each term. First, we have angle-side angle, or the ASA congruence postulate. It means that if two angles in the included side of one triangle is congruent respectively to two angles in the included side of another triangle, then the triangles are congruent. Next, we have included side. Included side is the side between two angles. Next, we have two-column proof. Two-column proof is one common way to organize a proof in geometry. Always have two columns, one for the statements and one for the reasons. Number each step. Next, we have vertical angles. Vertical angles are two angles formed by intersecting lines and facing in the opposite direction. Next, we have perpendicular lines. Perpendicular lines are lines that are at right angles or 90 degrees to each other. We use symbol shown on the screen to represent perpendicular lines. Next, we have right angle congruence theorem. According to the right angles congruence theorem, all right angles are congruent. For us to be able to understand the lesson that we are going to discuss, let us analyze the two given triangles presented on your screen. That is triangle ABC and triangle DEF. Can you tell which angles or sides that are congruent to each other? As you can see, angle A is congruent to angle D. Also, side AC is congruent to side DF. And last but not the least, angle C is congruent to angle F. If you will notice, side AC is the included side between angle A and angle C. And side DF is the included side between angle D and angle F. Since angle A is congruent to angle D, angle C is congruent to angle F, and side AC and side DF are congruent to each other, we can use angle-side angle or the ASA postulate in proving the congruence of the two triangles. Thus, triangle ABC is congruent to triangle DEF. Now, let us have an example on how to prove triangles congruence using ASA postulate. Given segment DG bisects segment EH and angle E is congruent to angle H, Let us prove that triangle DEF is congruent to triangle GHF using the two-column proof. For statement number 1, angle E is congruent to angle H. And the reason is because it's already given. Next statement is segment DG bisects segment EH. This statement is also given on the problem. For statement number 3, segment EF is congruent to segment HF. The reason is definition of bisector. It is because bisector divides a segment into two congruent segments, and in the figure segment EH is bisected into two congruent segments. These are segment EF and segment HF. For the fourth statement, angle EFD is congruent to angle HFG. And the reason is because angle EFD and angle HFG are vertical angles. And vertical angles are congruent. Since two angles, angle E and angle EFD, and included side, segment EF, of triangle DEF is congruent to its respective two angles, angle H and angle GFH, and included side, segment FH, of triangle GHF. Therefore, triangle DEF is congruent to triangle GHF, and that is by ASA congruence postulate. For our next example, segment CD is perpendicular to segment BA. Segment AE is perpendicular to segment BC, and segment BD is congruent to segment BE. Let us prove triangle BCD is congruent to triangle BAE. For our first statement, segment BD is congruent to segment BE. For the second statement, we have segment CD is perpendicular to segment BA, and segment AE is also perpendicular to segment BC. Both first and second statements are already given. For our third statement, CD is perpendicular to segment BA, and segment AE is also perpendicular to segment BC. We can say that angle CDB and angle AEB are both right angles. That is because perpendicular lines form right angle. Since angle CDB and angle AEB are both right angles, therefore, they are congruent to each other. Because right angles are congruent. By reflexive property, an angle is equal to itself. Thus, angle B is congruent to angle B. Since we have already discovered two angles, an exclusive segment of triangle BCD are congruent to two angles and its inclusive side of triangle BAE, we can now prove that triangle BCD is congruent to triangle BAE using ASA congruence postulate. For our last example, we have P is the midpoint of segment PS and angle P is congruent to angle S. Together, let us prove triangle PQT is congruent to triangle SRT. For our first statement, angle P is congruent to angle S. For the next statement, T is the midpoint of segment PX. Both statements are already given. For the third statement, we have segment PT is congruent to segment HT, and QT is congruent to segment RT. It's because midpoint divides a segment into two congruent segments. For our fourth statement, angle QTP is congruent to angle RTS. It's because vertical angles are congruent to each other. Since we have already proved that two angles and inclusive side of triangle PQT is congruent to its respective two angles and inclusive side of triangle SRT, therefore, triangle PQT is congruent to triangle SRT using ASA congruence postulate. So, those are the samples on how to prove two triangles are congruent. When writing your own two-column proof, always keep these things in mind. First, number each step. Then, start with the given information. Third, statements with the same reason can be combined into one step. It is up to you. Next, draw a picture and mark it with the given information. Fifth, you must have a reason for each or every statement. Next, the order of the statements in the proof is not always fixed, so don't worry. But make sure that the order makes logical sense. Next, remember, reasons will be definitions, postulates, properties, and previously proven theorems. Given is only used as a reason if the information in the statement column was given on the problem. Last, use symbols and abbreviation for words within proofs. For example, we use congruent sign to represent the word congruent. We also use angle sign to represent the word angle. So that ends our lesson on proving congruence of triangles using ASA congruence postulate. Again, this is Mr. Herbert Evangelista saying good luck and God bless. Have fun learning. Bye.